Okay, let's get started. Reactions in solutions. So as I said earlier when we were going over this stuff, it's going to mostly deal with water-based solutions. Water is the most common solvent that we're going to use. This is a particulate diagram, and what we have here, it looks like to me we have a salt molecule compound, and it is being dissolved in water. So what we can, yes, Shreya. I just see a positive and a negative, and one positive and one negative to one, so I'm thinking NaCl. It could be Ki, but it's a salt because it's an ionic compound. All right, we go back. I don't know if you were told this, but any salt is an ionic compound. If I say a salt, I'm not talking about the stuff that you're putting on your popcorn or your French fries. I'm talking about anything that has a positive and a negative bonded together.
So there doesn't have to be a sodium in it? Or
No. No. Okay. So what we see here is the following. We see a positive and a negative charges making up this lattice, okay? The greens are the negatives and the little ones are the positive, the cations. And yes, I would remember that your anions are the larger ones. Big fat anti-an, and then we have our positive cat ion, so small kitty cat. A lattice is going to be that, like the makeup, like a crystal. And you know, like lattice, rose lattice, how it's like all intertwined together. Crisscross. Like on a pie, on a cherry pie, how it's all nice and has that lattice. That's a lattice. Okay. So what you're going to see is you have your salt, and what happens is water, because of it, how it's made up, is it wiggles its way in between each one of those positives and those negatives. So let's draw a water molecule. So here is my oxygen and my two hydrogens. The oxygen has what type of charge? Negative. So this is a partial negative. That is this. It's like a 8 without the last part of the arm. That is partial negative. And then you have your partial positives on each one of your hydrogens. It means it's not, if I have a hydrogen by itself, it's fully positive. But then when it hooks up, it's sharing part of its.
It's partial to itself.
Yes. Okay, so here we're going to, water comes and wiggles its way in. So we have our cation and our anion. What part of water is going to be attracted to the anion, the negative? The hydrogen or the oxygen? Hydrogen. So the AP will ask you to draw this interaction and to draw it correctly. And then what about the cation? What's going to be attracted to the cation is your oxygens Okay, and so this is how we would draw this. You need to get used to drawing the water dissolving the ionic compound like I have here. Now what if it was a polar molecule? Somebody remind me, what is a polar molecule?
It's one that has. It's bent.
It's bent, okay. So it has a area of
One's more positive.
yeah. One's more positive and one's more negative. So if I have a polar molecule, say sugar, and it has a partial positive, let me go to a different color, a partial positive and a partial negative side, then we would expect that the oxygen molecule would be over here, turned that way, and then over towards the negative we have the hydrogen molecules, the water turned that way. Okay, so does that make sense how I'm drawing them? Polar is an unequal distribution of the charges. So one is sharing more than the other. Yes.
I have a question. So I know when you have molecules or elements, there was like 8 like pairs or something that they could have, right? 8, and that's all molecules can have, right?
Valence electrons.
That's what it was.
Yes.
Okay.
Now somebody asked me earlier, why did I draw a 5 on one and 4 on the other? That's all I could draw in there. If you've taken the AP exam, they'll say draw 5, no more than 5 oxygens per every whatever, or 5 waters per every. They're going to be specific. They're going to tell you what they want. Yes.
What's the name of the YouTube channel? Because I was trying to find it whenever we had our test last time.
I don't have a name. You just have to go to homeroom and go to the links.
How much is that?
Wait, it doesn't let you look at other like a bunch of videos. You have to have a specific link for the video.
And I go, each day has the link. Each day, like tonight, I'll put the link up here and you'll go today's date and go. It says link to 9/11's lecture. Link to 9/12 lecture. Huh?
Does the other class like get to talk?
Yeah, Marcus asks a lot of questions.
I'm recording this one right now.
Oh, really?
So, yes.
These nuts!
I should not have told you that.
So what are you recording on your iPad?
Yeah, I record it on my iPad and then I upload it to...
It has really good audio.
Yeah.
I wasn't going to, but the last one I messed up. There's 10 official in there.
I can't wait to watch this when I get home. I'm trying to fast forward to that part. Bro, you want to hear a funny story this way? So, I had Miss Gallagher for English and for my freshman.
Refocus. All right, here I kind of messed up when I was doing your notes. So if you go over to the next slide or the next page, we're going to label these. So the top one, I have a really bright light. So that is probably a strong electrolyte.
Is that like that thing that you have that lights up only half the time?
Uh-huh. And then we have a weak electrolyte. And this one doesn't light up at all, so it is a non-electrolyte. So somebody tell me, define for me what an electrolytic or an electrolyte is. Don't say Gatorade.
I was going to say body armor.
Yes, Shariah.
Is it like a solution that conducts?
A solution that conducts electricity. Yes, thank you. A solution
So wait, if I drink electrolytes from the Gatorade, then I get electrolytes?
that conducts.
There's no wrong way to spell it. That was in their commercial or something.
Miss White, Jane has a hypothesis.
Oh,
Can
no.
you test it out?
Okay. So, what do we need for us to be able to conduct electricity? What is needed? Huh? A positive and a negative, and we call positive and negative ions. Thank you. So we need ions. All right. So, strong electrolytes. Somebody tell me what makes up, what are strong electrolytes? What can be a strong electrolyte?
Is that on the front level things?
No, we're right here. I'm over to the
I
side.
mean, whenever we're talking about strong electrolytes.
Oh, you can do it there or you can do it over here.
But do the electrolytes from Gatorade conduct electricity?
Yeah, they do.
But it's mostly sugar. That's what the electrolytes are. It's sugar.
No, electrolyte. Sugar is not electrolyte. Salt. Okay, what kind of compound is salt? Ionic. So it has to be a soluble.
Is this for strong?
Yes, ionic compound. If it's not soluble, then it can't go into positive and negatives. And we're going to actually talk about those insoluble compounds. And that will be part of your solubility rules. So soluble ionic compounds are strong electrolytes. What else can be a strong electrolyte? We learned it towards the end of last year. They start with A's and B's.
Acids and bases.
And what type of acids and bases?
The strong one.
The strong ones, good. Strong acids and the strong bases.
So the acids you don't
What would not conduct electricity? Covalent. Covalent compounds such as sugar. Or if it's dissolved in water, it would be a polar compound, polar covalent compound. Those do not conduct electricity. Sugar, as we drew a while ago, can dissolve in water, but it doesn't break up into ions. And so since it doesn't break up into ions, it cannot conduct electricity. Non. So what would be our weak ones?
Oh, weak acids.
Weak acids and bases.
But insoluble ionic compounds.
No. Insoluble, they don't dissolve, so they wouldn't.
What about partial soluble?
No.
Is that a thing?
No.
Wait, whoa. That idea. Is Jello a solid or a liquid?
What?
That's a big debate. I feel like Jello. I feel like it's a solid. Jello's a solid, but the liquid stuff. What is that?
Okay, so somebody tell me what makes a strong acid from a strong base? What? Don't tell me pH. What makes a strong acid from a strong base? Or a strong acid from a weak acid or
Does it have
base?
something to do with the amount of hydrogen?
Not the amount of hydrogens.
The willingness of giving up
The
the.
bonds.
Wait, what was the
One
question?
is stronger than the other.
One is stronger than the other. Why is that?
Oh wait, the difference between acids and bases?
The strong from the weak. 100% what?
How diluted they are?
What?
Molarity.
100% dissociation for them to break up into those positives and negatives. If every
She was literally right.
I don't understand.
It's polarity.
I don't understand.
All right, let's go. I'm going to draw a line here because I want to put some notes over here. All right. My thing says list whether each of the following is a strong, weak, or non-electrolyte. If it's strong, write the dissociation equation. I want to know what it's going to look like when it breaks up. So, first of all, though, we need to go talk about what's a strong acid or base. So, go back to strong acids. Can somebody tell me what are the strong acids? Hydrochloric acid?
Sulfuric acid.
No.
Nitrous acid.
No, you said sulfuric. Yes, you're right. Sorry.
Okay.
But binary. Tell me binary. What are the binary ones? Which means it's H and something else. HCl?
HF.
No. No.
Wait, why is HF not one?
It's just not.
Oh.
Okay, I'm going to tell you right now, here's a way to remember them. I have a little mnemonic in my head, and this is how I remember them. So everybody remembers the diatomics?
No.
Yes.
Okay,
No.
so
I bring clay to our.
4.
For our.
Okay, Shariah, tell me, how do you know, what are the 7 diatomics?
I bring clay for our new house.
I bring clay for our new house. I bring clay for our new house.
I bring clay for our new. Oh.
Okay, so the binary is I bring clay. HI, HBr, and HCl. So your strong acids are just I bring clay. Now we have our ternary, which are our oxyacids. and I don't memorize these. This is how I remember it, is you have 2 or more oxygens than hydrogens. 2 or more O's than H's. So if I have HNO2 versus HNO3, which one's strong and which one's weak?
The 3 is the strong.
The 3 is the strong, and the 2 is the weak acid. Okay? I don't go memorize them. I bring clay, and then 2 or more O's than H's.
So in I bring clay, it's all of those. So it's nitrogen oxide.
No, for I bring clay, it's just I bring clay. And then any carbon containing, no matter how many O's there are, is always weak. Containing are always weak. So any acid with a carbon is a weak acid.
Okay, question.
Mm-hmm.
So, actually, never mind. I'm going to write it down because I'm coming after school. I don't want to.
Okay. All right, for the bases. So bases are our OHs, our OH group. So does anybody remember what the strong bases are? Okay, it's group 1, anything in group 1, and the bottom of group 2. And when I say the bottom of group 2, I mean strontium and barium. Any other is weak. Any nitrogenous bases, such as ammonia, is weak. So NH3 and other nitrogen-containing bases
What is SR again?
strontium.
I should stop calling it sriracha.
I have a mnemonic and strontium's in it, and I call it Sri Lanka.
Sri Lanka?
Sri Lanka.
Like Sri Lanka?
Sri Lanka.
Sri Lanka.
Okay, so HClO4. Strong, what? Just classify it first as either strong acid, strong base, weak base, or ionic or covalent. So it's a strong acid. Therefore, my 3 little dots, it's a strong electrolyte.
Wait, why are those 3 little dots there?
Therefore.
That means therefore.
Oh.
Calculus is now what all makes do that in calculus.
I do it all the time just because it's easier to do it.
We're using the same kind of graphs.
Wow, I've never learned this.
Okay, so how are we going to dissociate HClO4? It's going to break up into what 2 things? H minus, or H plus, and a ClO4 minus. Huh? H plus plus ClO4 minus?
Oh. Okay. And the ClO4 would not break apart?
Wait,
No.
what is plus H? Oh, it's 2
How come the
positive.
ClO4 can't break apart?
It's together. That's how it is. That's how it
There's
is.
no breaking.
So I could write and for the second plus, right?
So what does that mean? Why is that significant? Like the H plus ClO4?
H plus, that's the H positive, plus the chlorate, the perchlorate. All right, C6H12, what type of compound is it? It is a covalent. It is a polar covalent.
Okay, what is that?
What is a polar covalent? 2 nonmetals.
What do you write that covalent aren't those ones? Oh, okay.
It's not polar, it's
this is
nonpolar.
a
Nonpolar.
Wait, what are covalents?
Huh?
What are covalents?
Nonmetals. 2 nonmetals. Kaylee, what was the question?
Well, how can you tell just by looking at the elements whether it's polar or not polar?
You just have to draw it. I see that it's even, C6H12, so there's going to be 2 H's for every carbon, and that's going to make it symmetrical. So if it's symmetrical, then it's polar or nonpolar.
Oh, so this is a non-polar.
Okay, LiOH. Classify it. So nonpolar, therefore, hold on. Non-electrolyte.
Okay, so
It's a strong base.
This is a non-electrolyte.
Therefore, which one?
B.
B, yes.
Okay.
LiOH, how does it break up?
Li plus OH1.
Yes. It's a very amicable breakup. There we go. They're still friends. How about NH3? Weak what? Weak base. It's nitrogenous, and therefore it is weak.
Okay, so back to strong acid.
Uh-huh.
So the iron clay are the binary ones,
Mhm.
and the for our new house are those ternary.
No, for our new house, the Iberian clay for our new house, those are our diatomics. Those are just diatomics.
Oh, okay.
And then I just remember Iberian clay, all those diatomics are our strong.
Okay, but the other after clay is all irrelevant to acids.
Yes. Unless you have HF. And HF is a weak acid, but it has a strong pH. Does that make sense? You don't have to have you can have a very, very low pH and still be a weak acid. It's all about the dissociation. All right, NaCl. Somebody tell me what type of...
That would be a. No, I feel like it's not strong.
It's ionic, because we have a metal and a nonmetal.
Okay. I'm confused how this is an acid. I thought it had to have an H in there to be an acid.
What? NaCl? It's not an acid. It's an ionic compound.
we're talking about electrolytes.
An ionic is a metal and non-metal.
Yes. And therefore, it is a strong electrolyte. And how does it break up? NaCl produces Na positive plus Cl minus. What's the next one? Classify it as what it is.
A weak acid.
Weak acid. Therefore, it is a weak electrolyte.
So if it's a weak acid or base, then it's a weak electrolyte. But if it's a strong acid or base, it's a strong electrolyte.
Yes. And our last one, NH4Cl. So NH4 is a what? It's a polyatomic. Cl is a element. It's a nonmetal. So polyatomic plus a nonmetal makes what type of bond? Ionic.
Really?
Therefore, what type of electrolyte? It's strong. And NH4Cl is going to break into NH4 plus Cl minus.
So you only break up the strong electrolytes?
You only break up the strong. Because it's still because it's still it's 100% dissociation. So that's why we break them up.
Would you be able to tell the partial dissociation?
No, we wouldn't be able to tell how much it is, how much is breaking up. Okay,